Alright, we're going to talk about the mean value theorem for definite integrals. We talked about mean value with derivatives. That gave us the average rate of change. Here, if f is continuous, so no holes, jumps, asymptotes, anything like that, on the closed interval from a to b, then there's at least one number z in the open interval from a to b. So what this means is z, since it's in the open interval, z cannot be an endpoint. Or in other words, z cannot equal a or b. But what it's saying is there's some point, some x value, and they just use z for that x value, in between a and b, such that this formula works. It says the definite integral from a to b of f of x dx equals f of z times b minus a. So let's kind of interpret what that is really saying. So the left side, definite integral from a to b, that just means the area under this curve. Right, so we're looking at the area under this curve. And it says it's equal to f of z times b minus a. Well, b minus a, that would be right here, right? All that is the base of a rectangle that we're going to be talking about, right? This left side represents the area under this curve. This right side represents the area of a rectangle. The b minus a is the base. F of z is the height of that rectangle. So it's saying that there's somewhere in between a and b where there's going to be an x value z, and in this case it happens to be right in the middle. It doesn't always work out that way. But at that x value, if we use that as a height, what ends up happening is this right here is f of z, that's our height. We create a rectangle with the same area as that area under the curve. And if you look at this, think about what would happen if we took this portion right here, cut it off, spun it around, and fit it right in here. Alright, so this piece, if we put it right here, would create this rectangle. Right, so the area under the curve equals the area of the rectangle. That's what this formula is basically saying.
How do you determine where z goes?
How do you determine where z goes? Good question. So this one is kind of visually, you can kind of estimate where it goes, but we're going to take a look at some problems and figure out where z is. So that's what we're going to do after this page.
But like the main purpose is so that
We-
you can get there.
So what this means really now, this z, this f of z, is this height of this rectangle, but that's actually the average height of this function. Right? F of z equals the average height of f from a to b. That's where we get the mean value, mean average, right? If we were to look at this curve, every y value on this curve, add them all up and average that out, we would get this height. All right, so this f of z, this height, is the average height of all the points on this graph. If we took all those y values, added them up, and averaged them out, this is what it comes out to be. So that's the important thing that we're getting out of this mean value theorem. Same thing happens over here, although it's not as obvious as this one. There is a point somewhere, at least one point z, and in this case it's just going to be 1, where if we went ahead, and it might be a little bit off center here, but this rectangle would equal the area under this curve. And it doesn't look like a puzzle piece that fits perfectly in there, but just kind of approximately this would cover up this area. This is a little bit more obvious to see with the eye. But it happens with every function, at least one, as long as it's continuous. But like I was saying, the big thing to get out of this is the average value of f. Alright, so this f of z equals the average value of f. Or another way of thinking of it is the average y value, or average height of the graph. Right? F of z is that average value of f on the interval from a to b. So we have this formula. Instead of leaving the formula as it is up here, average value of f is just the f of z part. So if we want this formula to be just the f of z, all we have to do is divide both sides by b minus a. So our average value of f, I usually abbreviate it like this, instead of the f of z, average value of f is equal to 1 over b minus a times the definite integral from a to b of f of x dx. So the average y value of this function between a and b is going to be equal to this whole thing. So this is a formula you need to remember.